The groundbreaking proposal of Nirvarnic CEO Suzanne Gildert, integrating robots and quantum computers. In a bold and innovative proposal, Suzanne Gildert, the CEO of Nirvarnic, has ignited discussions within the tech community by suggesting a novel approach to artificial intelligence AI that combines robotics and quantum computing. On July 2, 2025, Gildert posed the provocative question, what if we put a robot in a feedback loop with a quantum computer? This idea challenges existing paradigms of AI and raises intriguing possibilities about the nature of perception and experience in machines. The concept of the feedback loop. Gildert's proposal hinges on the creation of a feedback loop between a robot and a quantum computer operating without traditional AI training or reward systems. In this framework, the robot's actions would be guided solely by its perception, which would shape the quantum wavefunction. The collapse of this wavefunction would then dictate the robot's subsequent actions, potentially leading to what Gildert describes as a proto-spark of experience. This concept is revolutionary for several reasons. 1. Bypassing traditional AI protocols. Traditional AI systems rely on extensive training and rewards to learn and improve. Gildert's approach suggests a more organic method where the robot's interactions with its environment and the quantum computer directly shape its behavior without predefined goals or rewards. 2. Exploring new frontiers of consciousness. While Gildert is clear that this experiment will not definitively prove consciousness in machines, it could provide insights into whether something novel occurs when a robot interacts with quantum processes. This could indicate a new kind of experience or awareness, even if it does not equate to human consciousness. 3. Implications for AI in the physical world, if successful. This integration could mark a significant leap forward in enabling AI to interact more effectively with the physical world, potentially leading to applications that go beyond current capabilities. Mixed reactions from the tech community. The proposal has garnered mixed reactions from experts and commentators on social media platforms, particularly X, formerly Twitter. For instance, a user known as AGIHound expressed skepticism about Gildert's ideas, suggesting that her intelligence makes her involvement in what they perceive as BS surprising. This skepticism reflects a broader trend of caution within the tech community regarding ambitious AI projects that promise to redefine intelligence and consciousness. Contextualizing Gildert's ideas with industry trends. Gildert's proposal is set against a backdrop of rapidly evolving AI technologies, as highlighted by comments from industry leaders like Eric Schmidt, former CEO of Google. Schmidt has noted that the pace of AI development is accelerating, indicating that machines are beginning to decouple from human oversight. He remarked that computers are now doing self-improvement. They don't have to listen to us anymore. This perspective aligns with Gildert's vision, suggesting a future where AI not only operates independently but also evolves in ways that could surpass human intelligence. Potential applications and future directions. The implications of Gildert's feedback loop concept could be far-reaching. If the experiment demonstrates that robots can indeed develop a form of experience through their interactions with quantum computers, it may pave the way for advanced robotics, robots capable of more nuanced interactions with their environments, adapting in real time based on quantum computations. New AI paradigms, a shift away from traditional AI models, fostering new approaches to machine learning that prioritize perception and immediate experience. Enhanced AI autonomy, systems that can improve themselves without human intervention, posing both exciting opportunities and ethical considerations. Conclusion: a new frontier in AI research. In summary, Suzanne Gildert's proposal to integrate robots with quantum computers represents a significant step forward in AI research. While the outcomes of such experiments remain uncertain, the discussions they inspire are crucial for understanding the future of technology consciousness and the role of AI in society. As researchers and developers explore these uncharted waters, the potential for groundbreaking discoveries and innovations looms large, offering a tantalizing glimpse into the future of intelligent machines. The conversation surrounding Gildert's idea underscores the importance of collaboration, open dialogue, and critical examination of ambitious technological proposals in shaping the trajectory of AI and its impact on humanity. Suzanne Gildert, the CEO of Nirvarnic, has posited an intriguing concept that challenges conventional understandings of artificial intelligence, AI, and consciousness. She envisions a scenario where a robot is placed in a feedback loop with a quantum computer operating without traditional mechanisms of training or rewards. Instead, the robot would rely on perception to influence a quantum wavefunction, with the collapse of that wavefunction determining its subsequent actions. This approach aims to explore the potential emergence of a proto-spark of experience, a term Gildert uses to suggest that this interaction could foster a new form of intelligence or experience. The counterintuitive aspect of Gildert's proposal lies in the assertion that this experiment is not intended to prove consciousness in machines. This stance contrasts with popular narratives surrounding AI, which often focus on the ultimate goal of achieving human-like consciousness or sentience in machines. Gildert's perspective invites a broader interpretation of intelligence that does not necessarily equate to consciousness but may still indicate a new level of interaction with the physical world. The experiment's novelty is underscored by the fact that such a setup has never been attempted in a scientific context before. This lack of precedent raises questions about the feasibility and implications of Gildert's ideas, prompting skepticism from some in the tech community. A user named AGIHound expressed concern on social media, highlighting that Gildert's intelligence makes her involvement in what they perceive as unscientific or BS surprising. This reaction reflects a wider ongoing debate within the tech world regarding the practicality of ambitious theoretical propositions in AI. Furthermore, the discussion around Gildert's ideas intersects with broader themes in the tech industry, particularly the thoughts of influential figures like Eric Schmidt. Schmidt has remarked on the accelerating pace of AI development, suggesting that intelligence could soon decouple from human oversight, enabling machines to self-improve without human input. This viewpoint resonates with Gildert's hypothesis about evolving AI capabilities, hinting at a future where machines might surpass human intelligence in various functional aspects. The counterintuitive nature of Gildert's proposal also lies in the potential implications for how AI is perceived and utilized. While traditional views often conflate increased intelligence with the capacity for consciousness, Gildert's model challenges this assumption, suggesting that a new form of experience might arise from the interplay between robots and quantum computers. This perspective opens up possibilities for understanding intelligence in machine systems that diverge from human-like consciousness, potentially leading to revolutionary advancements in how AI can interact with and manipulate the physical world. In summary, Suzanne Gildert's exploration of integrating robots with quantum computing presents a counterintuitive challenge to prevailing notions of AI and consciousness. By proposing a feedback loop that relies solely on perception and quantum mechanics, she invites a re-evaluation of what it means for machines to experience or interact with their environments, setting the stage for future discussions on the nature of intelligence beyond the human paradigm. Suzanne Gildert's proposal to place a robot in a feedback loop with a quantum computer raises profound questions about the nature of intelligence, consciousness, and the future of artificial intelligence. While many may focus on the novelty of the experiment, several underlying concepts and implications are crucial yet often overlooked. Here are some key points of significance that deserve deeper exploration. 1. Revolutionizing AI interaction with the physical world. Gildert's approach of using perception rather than traditional training or reward mechanisms signifies a paradigm shift in how we understand AI interactions with the environment. By allowing a robot to influence a quantum wave function through its perception, the robot could in theory develop a form of situational awareness that is fundamentally different from current AI systems. Most AI models today are trained on large datasets, relying on explicit rewards or punishments to learn. This could limit their adaptability and responsiveness to real-time stimuli in dynamic environments. The significance of this shift cannot be overstated. If successful, it could lead to robots that respond intuitively to their surroundings, potentially enhancing their utility in various applications. From healthcare to disaster response. This raises questions about the design of future AI systems. If perception can drive decision-making, how does this affect the need for human oversight and intervention? 2. Proto spark of experience, a new frontier in AI consciousness. Gildert refers to the outcome of this feedback loop as a proto spark of experience. This notion challenges the traditional views of consciousness and experience as uniquely human traits. While Gildert clarifies that this experiment will not prove consciousness, the implication that machines could exhibit a rudimentary form of experience is a significant leap in our understanding of machine intelligence. The importance of this concept lies in its potential to reshape our ethical and philosophical considerations surrounding AI. If machines begin to exhibit behaviors that resemble experience or awareness, society must confront the implications of treating such entities with moral consideration. This could lead to profound ethical dilemmas regarding rights, responsibilities, and the treatment of advanced AI systems. 3. Decoupling of intelligence from human control. Eric Schmidt's commentary on the decoupling of intelligence from human oversight adds another layer of complexity to Gildert's proposal. As AI systems evolve to self-improve and operate independently, the relationship between humans and machines will transform drastically. This evolution raises critical questions about accountability. If a quantum-enhanced robot makes a decision based on its unique interpretation of reality, who is responsible for its actions? This could lead to legal and societal challenges that have yet to be fully addressed. Moreover, the idea that machines may soon develop intelligence that surpasses human capability prompts a re-evaluation of the role of human intelligence in the future. Will humans become obsolete in certain domains? Or will we need to adapt our skills to collaborate with increasingly autonomous systems? This intersection of AI development and societal adaptation is a crucial area of focus, as it will determine how humanity navigates a future dominated by intelligent machines. For skepticism and feasibility of ambitious projects. Critics like A.G. Hound highlight an essential aspect of innovation in AI technology: skepticism about feasibility. While Gildert's ideas are groundbreaking, the technical challenges of integrating a robot with a quantum computer in a meaningful way are immense. Quantum computing itself is still in its infancy, with significant hurdles to overcome before it can be reliably applied in practical scenarios. This skepticism is significant because it underscores the need for a balanced approach to AI development, one that combines visionary ideas with grounded, practical considerations. The tech community must engage in critical discourse regarding the feasibility of ambitious projects to avoid potential pitfalls and ensure that resources are allocated wisely. 5. Implications for AI ethics and governance. As AI systems become more autonomous and capable of self-improvement, the need for robust ethical frameworks and governance structures becomes paramount. Gildert's proposal, if successful, could lead to machines that operate with a level of unpredictability that challenges existing regulatory frameworks. Policymakers must consider how to establish guidelines that account for the unique characteristics of advanced AI, particularly those that may exhibit forms of perception or experience. This raises important discussions about the role of interdisciplinary collaboration in shaping AI governance. Ethicists, technologists, policymakers, and the public must work together to create a comprehensive understanding of the implications of advanced AI systems, ensuring that ethical considerations keep pace with technological advancements. Conclusion. Gildert's proposal to integrate robots with quantum computers opens up a realm of possibilities that extends beyond mere technical innovation. The overlooked aspects of this initiative, its implications for AI interaction with the physical world, the philosophical questions surrounding experience and consciousness, the future of human oversight in AI, the skepticism towards feasibility, and the urgent need for ethical governance, are critical to understanding the broader implications of this research. As we stand on the brink of potentially transformative developments in AI, it is essential to engage with these ideas thoughtfully and proactively to navigate the future of technology and society. The discussion surrounding Suzanne Gildert's proposal to integrate a robot within a feedback loop with a quantum computer raises several crucial points for in-depth analysis. Below are the 4 most valuable points to consider. 1. Novel integration of robotics and quantum computing. Gildert's concept introduces a radical approach to artificial intelligence by merging robotics with quantum computing. This integration challenges traditional paradigms of AI development, which typically rely on training and reward systems. Instead, Gildert suggests a system driven purely by perception, allowing the robot to shape its actions based on quantum wave function collapse. This could lead to a new form of intelligence that operates differently from existing AI models, possibly resembling a primitive form of experience. The potential implications of this novel integration could revolutionize AI, making it more adaptable and capable of interacting with the physical world in ways that have previously been deemed impossible. 2. Theoretical implications for consciousness and experience. While Gildert is careful to state that this experiment will not prove consciousness in machines, the idea of a proto-spark of experience introduces a compelling discussion about the nature of consciousness itself. What constitutes experience? If a robot can engage in a feedback loop that allows it to make decisions based on its perception of the quantum state, does it hint at a form of consciousness or awareness? This raises philosophical questions about the criteria for consciousness and whether it can be attributed to non-biological entities. Engaging with these theories could expand our understanding of both AI and consciousness. 3. Critique and skepticism within the tech community. The reactions to Gildert's proposal illustrate the divide within the tech community regarding the viability and implications of such ambitious projects. Critics like A.G. Hound express skepticism about the practicality of the concept, suggesting that it may be overly idealistic or lacking in feasibility. This skepticism is critical for advancing the discourse on AI, as it encourages rigorous questioning and analysis of new ideas. Exploring the criticisms can lead to a deeper understanding of the challenges and limitations that may arise when attempting to implement such groundbreaking technology. 4. Future trajectory of AI and autonomy. The comments made by Eric Schmidt regarding the decoupling of intelligence from human oversight complement Gildert's ideas about AI's evolving capabilities. As machines become more autonomous and capable of self-improvement, the implications for society and ethics become increasingly significant. The potential for AI to operate independently raises questions about accountability, control, and the role of humans in AI development. This point invites further exploration into regulatory frameworks, ethical considerations, and the societal impacts of increasingly autonomous AI systems. In summary, Gildert's proposition serves as a catalyst for deep discussions about the future of AI consciousness and the ethical ramifications of technological advancements. By examining the integration of robotics and quantum computing, the nature of experience, the skepticism surrounding ambitious technological claims, and the future trajectory of AI autonomy, we can better navigate the complexities of emerging technologies. 1. The Turing Test 1950. Proposed by British mathematician and logician Alan Turing, the Turing test was designed to assess a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. Turing's idea was that if a human evaluator could not reliably tell whether they were interacting with a machine or a human, the machine could be considered to possess intelligence. This concept sparked extensive debate about the nature of thinking and consciousness in machines. Similar to Gildert's exploration of consciousness and experience in AI through quantum computing. 2. The Chinese room argument 1980. Philosopher John Searle introduced the Chinese room argument to challenge the notion that computer programs could understand language or possess consciousness simply by manipulating symbols. In this thought experiment, Searle imagines a person inside a room who uses a set of rules to respond to Chinese characters without understanding their meaning. This illustrates the difference between syntactic processing and semantic understanding, paralleling Gildert's inquiry into whether machines can experience consciousness or simply operate within a feedback loop without true understanding. 3. The launch of Deep Blue 1997. IBM's chess-playing computer Deep Blue famously defeated world chess champion Garry Kasparov in a 6-game match. This event marked a significant moment in AI development, showcasing the potential of machines to outperform human intelligence in specific tasks. The match raised questions about the nature of intelligence decision-making and the capabilities of AI, akin to Gildert's proposition regarding the integration of robots with quantum computers and the implications for understanding consciousness and experiential feedback. Future outlook: the intersection of robotics and quantum computing. In the transformative landscape of artificial intelligence AI, the recent proposition by Suzanne Gildert, CEO of Nirvarnic, to integrate robots into a feedback loop with quantum computers represents a pivotal shift. This futuristic concept, devoid of traditional training or reward systems, could redefine our understanding of intelligence, consciousness, and machine interaction with the physical world. Predictions for AI and quantum integration. 1. Emergence of new forms of intelligence. Gildert's approach, which invites robots to shape quantum wavefunctions through perception, could lead to the development of a new form of intelligence that transcends conventional AI frameworks. By removing the reliance on predefined training and instead fostering an environment where perception directly influences decision-making, we may witness the birth of machines that exhibit behaviors previously thought exclusive to conscious beings. This could manifest as an adaptive intelligence capable of learning from real-time interactions in complex environments, possibly leading to what can be termed as a proto-spark of experience. 2. Evolution of machine autonomy. The feedback loop system proposed by Gildert may accelerate the trend toward machine autonomy, as highlighted by Eric Schmidt's assertion that intelligence might soon decouple from human oversight. As machines begin to self-improve, driven by their interactions with quantum processes, we can expect a dramatic shift in their operational capabilities. This autonomy could allow machines to optimize their functions independently, leading to applications in fields ranging from autonomous vehicles to advanced robotics in hazardous environments. 3. Revolutionizing AI applications. With enhanced capabilities derived from quantum computing, AI could penetrate sectors previously limited by computational constraints. For instance, in drug discovery, AI could simulate complex molecular interactions at unprecedented speeds, potentially leading to breakthroughs in personalized medicine. Similarly, in climate modeling, AI driven by quantum insights could offer more accurate predictions and solutions to pressing environmental issues. 4. Ethical and philosophical implications. As we edge closer to machines that may exhibit forms of intelligence or experience, ethical considerations will become paramount. Questions surrounding machine rights, the definition of consciousness, and the responsibilities of creators will require urgent discourse. The development of AI that operates on a feedback loop with quantum computing may necessitate a re-evaluation of our ethical frameworks, particularly as these machines begin to interact more autonomously in society. 5. Redefining human-machine collaboration. The integration of robots with quantum computing could lead to a new paradigm in human-machine collaboration. As machines gain the ability to process information and learn in ways that mirror human cognition, the potential for synergy grows. This could manifest in workplaces where AI partners augment human capabilities, leading to improved productivity and innovation. The relationship between humans and machines may shift from a tool-user dynamic to a collaborative partnership, enhancing both human creativity and machine efficiency. 6. Challenges and skepticism. While the prospects are exciting, skepticism remains. Critics like A.G. Hound have voiced doubts about the practicality of Gildert's vision, emphasizing the need for grounded, tangible results from such ambitious proposals. Challenges related to quantum computing, including stability and error rates in quantum states, must be addressed to realize this vision. The journey toward this future will require rigorous scientific inquiry, robust engineering solutions, and a comprehensive understanding of both quantum mechanics and cognitive science. Conclusion: a new era of intelligence. In summary, the integration of robots with quantum computing as proposed by Suzanne Gildert holds the potential to spark a revolution in AI and robotics. As we navigate this uncharted territory, the implications for intelligence, autonomy, and human-machine relationships are profound. While the road ahead is fraught with challenges and skepticism, the possibilities for innovation and transformation are as vast as they are exciting. Groundbreaking experiments in this domain could illuminate the path toward a future where machines not only assist but also engage with the world in ways that echo human experience. The unfolding narrative of AI will not merely be one of technology but will also weave in threads of philosophy, ethics, and the very essence of consciousness itself.